nice online platform. Myself, Shubhodip Saha, Head of the Department of Electrical Engineering at Surendra Institute of Engineering and Management, Shiliguri. It's my privilege and honor to welcome our guest speaker, Professor S. Balasubramani, who will be presenting the online training program on Introduction to Simulation Tools via today's webinar, specially focusing on Autodesk Tinkercad. Professor S. Balasubramani is an application engineer at ARP Innovations who is carrying doctorate in forecasting and optimal power flow as research scholar in Anna University and lifetime member technical forums of ISTE and ITE. He has worked as assistant professor in the electrical and electronics engineering department in Jerusalem College of Engineering for 7 long years and has deep knowledge in subjects such like electrical, electronics and robotics. He has published around 3 international journals and 4 national journals and 7 conference papers. He has been organizing various robotic learning sessions for leading group of schools and also conducting soft classes along with hands-on training for premium institutes in and around Chennai. His specialization are in softwares like Arduino, MATLAB, ETABS, Proteus, and also provide hardware applications and integration for the above mentioned softwares. So, without taking much time, I would like to request Professor S. Balasubramani to kindly present the webinar. So, over to Balasubramani, sir.
Yeah, that was a nice introduction about me. Okay, let's go on with the session. Can you see my screen? Tinkercad? Hello?
Yes, Bala.
Yes, Bala. Yes.
Okay. Okay. Let me start with it. So today we are going to see about Tinkercad software. Okay, it is an online free software. It can be used both by students and faculty. Okay, for students limit, what they can do is they can join in as virtual classroom so that the instructor can teach them on an one-to-one basis or on group basis. Okay, with respect to this software, it is an freeware. Okay, it is completely online. So the main advantage of it is all the files are stored directly in online itself. So if you need any files means you can download them or simply you can go with it. So what you can do is just go to your browser and type tinkercad.com. So you will be getting into a normal web page. Okay. So in that web page, what you can do is you can just join now or sign in. So what I will be doing is I will be signing in. So I usually have already signed in with my Gmail account. So this is already signed in. So inside the Tinkercad, one minute. Join now. One minute, I am just logging in. Okay, now you are able to see this Tinkercad, right?
Yes, Bala.
Yes, Bala.
Okay. Here you have almost 3 to 4 types of softwares inside this. So the first one is 3D design. So here what you can do is you can create your own 3D text, images and all, and then you can use your 3D printer and print the parts which you need for your project or day-to-day lives. or for your educational purposes. Okay, next one is your circuits. So today we will be dealing with circuits. So with respect to circuits, so what you can do is you can come here. These are the already circuits which I have designed or used before. So let's start with a new one. So create a new circuit. So next you will be asked to fill up a name for the circuit. So let's fill up this name as example 1. Okay. Let's see with what are all the icons available. So this is going to be your rotate icon for rotating your components, and this is going to be your delete, undo and redo, and this is annotate, view or hide components, and this is going to be zoom to fit. Okay, most of the time we will be using the zoom to fit icon. Next you have a toggle window, so where you can write your code here. So the main advantage of this Tinkercad is you will be having two methods to write the codes. Okay, one thing is your regular Arduino code which you usually write. The second method is block type of coding, so you no need to type and remember syntax and all. So what you can do is you can simply drag and drop, fill in the points what and all you needed, that's all. So your code will be auto generated here. Okay, next this is for simulation, start and stop, and here you can export your circuit to eagle file. Okay, from the eagle file what you can do is you can PCB also. Okay, so we have almost all the advantages with this online software. Okay, so let's see with the basics components. So the components available here are resistor, LED, a push button, potentiometer, capacitor, switching, 9-volt batteries, coin batteries, 1.5 volt batteries, breadboard. Okay, let's start with batteries. Okay, just drag and drop, so your battery will be available here. So here you can give the name for the battery. Next is the number of batteries you needed. So if you need 1.5 volt, 1.4 volt of single battery is enough. Next, if you need two batteries, so add up two batteries in series. Okay, so you can go up to four batteries. Four batteries is the maximum limit. And next is you can select the type. It's going to be a AA or a AAA batteries. Whichever battery you want, you can add them. Next, here it is, you have a built-in switch. So built-in switch, you can switch it on, so you are not able to visualize the batteries. So what happens is when you start the simulation, it automatically gets on. Okay, when you stop the simulation, the circuit automatically gets switched off. Okay, this is little bit advantages. Okay, let's move with the two batteries. Okay, next thing, next we will go with a simple LED connection. Okay, LED connection and motor connection. So let's see with a motor. Okay, this is a normal DC or toy motor which usually runs at lower speeds. Okay, so while connecting you have to be little careful. Little careful, what I mean is you need to find out the terminals correctly. Okay, so to solve that problem, what they are doing here is they are giving color coding here. So red is for positive and black is for negative. So when you move your mouse pointer over the terminal, what happens is it will show you it is a positive terminal. Okay, what you can do is you can simply connect the positive to here. Sorry, it's not connected. Next is negative terminal to negative. Okay, so then start your simulation. So now you can see that your motor is running at 97 rpm. Okay, so at this small amount of voltage, so what happens is if I increase the voltage, automatically it updates it, and the speed of the the speed of the motor, that is the rpm, is increasing gradually. Okay, so with respect to four batteries. So next is what we can do is here you can visualize the amount of voltage inflow, current flow through the motor, how much amount of current a single motor is consuming. Okay, usually while designing your robotic projects, what happens is your battery gets drained off very easily. Okay, or most of the time what happens is while drying we will be using some 9-volt batteries. Okay, so those 9-volt, this is the most common battery you will be using while preparing some drones, or sorry, not with respect to drones, uh, with some toy works. Okay, so this is not a rechargeable battery. Here we can, what we can do is we can use some rechargeable batteries, but we have to design or think about it, how much time my robot has to run. Okay, if it is a line following robot, for how long the track it is, how long it has to run, so what is the power capacity needed for the battery. Okay, all these things you can visualize here. So what we can do is we can simply erase this, and next what we can do is we can use our multimeter. Okay, so use a multimeter, so connect it towards the terminals instead of the negative line. So I'm making my current to pass through the multimeter and then to the motor. Okay, next I am starting the simulation. Okay, so I have to keep it at so here it is similar, just like your real-time meters. Okay, so if it is in voltage mode, your motor doesn't runs. Okay, so you have to switch it to ammeter mode, so only then it allows the current to flow through it. So now what you can see is it runs at 187 rpm and consumes around 254 milliamps. Okay, the same thing what you can do is uh, you can connect another multimeter and then start a simulation, so that you can find the total amount of power consumed. Okay, so while I am using 4 batteries, next is what if I am using 3 batteries. So what happened is my voltage level reduces, and same way my current consumption reduces, and my speed is also getting reduced. Okay, so all the factors can be taken into account. So how many motors you are going to keep, so you can place the motors and then find out their respective speed, at what speed you want to run them. Okay, so if you want to control the speed, what you can do is simply you can place a resistance here, so that it allows, so that it drops the amount of current flow through it. Okay, this is one of the basic thing you can do with respect to this software. So this software has huge number of real-time projects you can do, or your lab experiments. Okay, most of the electrical students you have done with your circuits lab. Okay, so you might have, what you might have done is you might have burned most of the components, mostly resistors, inductors and all you might have burned in your lab. Okay, so let's find out why your resistor inductor got burned. Okay, so let me take a LED here. So okay, what we can do is let's remove this motor, let us keep this meters and all. So when you directly connect your voltage, so here this is going to be a positive supply. So same way when you take it and move it here, so you will be finding your anode, connect the positive supply to your anode. So what you can do is you can select the color of the line also. Okay, sorry, wire. So it is going to be red color. So for this what I can do is I can select it as black. Okay, so I have connected my LED to a battery directly. Okay, let me start the simulation. What happens is my LED got burst. Okay, here it gives me a comment such that the current through the LED is 487 milliamps, while the maximum amount of current which can pass through this LED is only 20 milliamps. Okay, so by sending in too much amount of current, what happened is my LED got burnt. Okay, so if you want to visualize the amount of current, so what you can do is same way you can connect your multimeter here and then run your simulation. So it is burnt. Okay, so the amount of current which got through it. So to avoid this, what you can do is you can place a resistor. Okay, so to reduce the flow of the current, what you have to do is you have to use some resistors. So by placing a resistor, what happens is your LED is saved. Okay, so let us place a resistor here. So the one more advantage about the software is, so you can vary the value of your resistor. Okay, so here I have used it as 1 kilo ohm. So what happens is, if I change the value of the resistance, the color coding also changes instantly. Okay, if you want to visualize, you can visualize it. So 100 kilo ohm. So at each time what happens is, your resistance value also changes, color coding also changes. So you can visualize the color code and find the resistor directly. Okay, so zoom to fit. So using it again. So next thing is, I am starting the simulation. So what happens is, my LED is glowing on. Okay, so you are not able to see it clearly. Okay, there will be only a slight difference in visualization, so it is not visible here. Okay, so if you want a clear visualization, so that I can use my this LED. So this is going to be my cathode, this is going to be my anode. So blue color it is connected. Okay, so you are able to see the LED glowing. Okay, so initially why it was not glowing? Because of the high resistance value. So by reducing the value of resistance, you can see that the brightness of the LED is also getting increased. Okay, so same way what happens is, if I reduce the resistance to a very low value, my LED gets blown off. Okay, the same thing happens to your capacitors and also to your inductors. So you have to be very careful while designing your circuits and connecting them. Okay, so here you will be having a hell lot of advantage, so that you can simply place your components without any cost and check your circuits whether they are working out properly or not. Okay, so the next thing is, let's go on to, so here you will be having some few examples. Okay, so let's go on with, so let me say you what are all the components available. So you will be having a normal push button. Okay, let's see with the push button. So what happens here is, okay, so while you push it up, what happens is, it's get connected. Okay, so you can use these type of push buttons or uh, a slide switch. Okay, so slide switch, what happens is, it is just like your normal home switch. So just connect it here, and then you will be able to switch on and switch off, on and off conditions. Okay, next you have your potentiometer. So with this spot, what you can do is, you can vary the resistance of your system. So let's connect a pot here instead of this. So when you connect a pot, what happens is, your LED instantly it gets blown off. Okay, so what I'm going to do is, I am going to change the value of the resistance. Okay, kilo ohm, let it be, sorry, already I have a resistor here. So here what you can do is, you can make your visualizations. Okay, so how much amount of resistance you need, what you can do is, you can add it up, and then you can find it out what I my LED or component, at what is the maximum amount of value it can withstand. Okay, okay, next thing is, next you have your DC motor. Okay, same way, just like your normal motors, you will be having your instead of toy motor, you will be having your DC motor. So with respect to this DC motor, uh, it performs the same aspect just like your toy motor. Okay, but the only thing is you can see its visualization. The thing here is it runs at a higher RPM speed. Okay, this DC motor is a non-geared DC motor. Okay, usually the toy motor which you saw there, that yellow color motor, this is an hobby gear motor. So it is connected to gears. Okay, this is similar to the toy motor which you usually get in your toy cars and all. Okay, let's see some basic examples. Okay, so let me clear this table. So next, here you have to delete each and every component by simply clicking it on. Okay, so you cannot click it or do something directly. Okay, let's go on with the LED switch. So this is a normal 3.5 volt sorry 1.5 volt 3 volt battery. So what you can do is you can simply switch it on. During simulation your LED glows, or you can connect a motor or something like that. Okay, next is RGB LED. Let's see how your RGB LED. So your RGB LED is connected to three LEDs. So normally, so this is going to be your cathode terminal and this is going to be your anode terminal. So you'll be having three anodes. So here the LED used here, it is common cathode. Okay, usually while purchasing LEDs, get to know about whether it is common anode or common cathode. Okay, so here it is going to be common cathode, so this is going to be the negative terminal. So what you are going to do is you are going to give the positive supply to whatever the color you want. So what happens is at that particular point of time, that particular LED starts glowing. Okay, let's start it. So if I press red, what happens is the red color alone gets through here, blue, green. Okay, so if you have doubt, what you can do is you can just erase this thing. This will give you a clear view of what they have done. Okay, the cathode is connected to the ground. So what happens is start the simulation. So now you can visualize red, blue, and green. Okay, this is how you use your tricolor LED. Okay, next is with respect to your sensors. Okay, now you can use your sensors also into this system. So let's go with it. uh, Let me take a running of a DC motor. So instead of a normal potentiometer, what I have done here is I have connected a LDR. Okay, all of you know what a LDR is. So it is light dependent resistor. So based on the amount of intensity of light falling on it, its resistance varies. Okay, let's start a simulation. So what you can visualize here is it is running at 6 rpm. Okay, so click on here. So what happens is it is under full dark condition. Okay, while moving it on further and further, what happens is the amount of current flow in it increases, so it rotates at higher rpm levels. Okay, so this is the total amount of rpm it is running through. So maximum it runs at 1913 rpm. So you can vary the speed of the motor with respect to your LDR. So one thing you have to mind here is not to visualize the speed with respect to the graphics here. Okay, the graphics and this are little bug which has to be adjusted. Okay, so let's move on to the um, uh, next example, which is going to be your PIR sensor. Okay, PIR sensor is nothing but a normal human detection sensor. Okay, you might have visualized this PIR sensor in most of your real times. Okay, where it is because of your usually you used to go to malls. What happens is the door opens automatically. Okay, so at the top of the door you can able to see a small black color box. Okay, so that black color box has your PIR sensor. So what it does is it sends the human heat level. Okay, so with respect to the human heat, what happens is the circuit gets connected. Okay, let me start a simulation. Okay, when I click this PIR sensor, what happens is I am able to see a dot. Okay, so when this dot is nothing but our human. Okay, when it falls in the region, okay, in the region of the PIR sensor, the circuit gets activated. Okay, and this light can be connected just like what I can say it is. So by instead of glowing this light, what you can do is you can connect it to a door mechanism. So what happens is your door opens automatically. Okay, so when you move away from there or move closer after the door, what happens is your door gets shut off. Okay, so this is a real-time example. With the help of PIR sensor, you can normally do your unmanned door stuff and all. Okay, so these are the basic stuff which you usually do here. Next is you can get into Arduino. So for doing with Arduino, you have your special Arduino editor, or here you can just simply visualize it. And here you have circuit assemblies. Okay, these are the same. And when you finally move on to the all, what happens is you will be able to visualize all the components available here, circuit assemblies and all, everything you are able to see here. Okay, so same way with respect to components, if you click on to that level, so what you can do is you have diodes, capacitors, inductors, and furthermore if you move on, you will be having your tilt sensor. Most of the sensors are available with respect to Arduino. They are very useful while doing your Arduino circuits and all. Next is your temperature sensor, keyboard, dip switch. Okay, so you are able to see RGB LEDs, LED NeoPixel lights, Neo rings. Okay, so these are all the NeoPixel strips. Okay, what are these NeoPixel strips is, one minute, let me zoom it up. These NeoPixel strips are usually used while decorating um, your home. Okay, or a table with the strips of lights. Okay, so these are of strips of light. So this is going to be your LED. So simply what you have to do is you have to connect a ground, a 5 volt, and a digital input. So whenever the digital input is on, what happens is the LED starts glowing. Okay, so you can have 8, 10, 12 or 16 strips, how much amount of voltage you needed to give, or how we are going to control them. So you can vary the on and off of this system with respect to your by using PWM techniques. Okay, a simple Arduino, you can use it up and you can do it. Next is you have your servo motors here. Okay, so we will see the servo motor operation when we are moving with up to Arduino. So micro servo. So this micro servo, you can connect it with the Arduino, but for this servo, what happens is you need some external structures. Okay, to connect them. Next you have IR remote, piezoelectric 7-segment display, LCD display. So potato batteries, lemon batteries, just like your uh, school level experiments are also available. Next you have your Arduino board, a 10T board. Okay, so next we have your power supply. Next we have your function generator and oscilloscope. Okay, so let's see about, visualize about this function generator. Okay, so with respect to this function generator, to visualize this function generator, we will be needing a oscilloscope. Okay, let me connect them directly. Okay, so that so this is similar to the oscilloscope which you use in your lab. Okay, so just you can start your simulation. Okay, so what you can do is you can select the amount of voltage. Okay, and then you can select the this is the offset level where you want to keep it. Okay, this is going to be your frequency. Same way, what you can do is you can select the times per division, that is the frequency which you need to visualize in your oscilloscope. Okay, so I have given it as 1 kilohertz. So, okay, what I can do is when I keep on reducing the frequency, what happens is I am able to see the waveform. Okay, here it is going to be 100 millisecond. So let us visualize the sine waveform, okay, of our house, which is at the frequency of how much, 50 hertz. Okay, so the time division is going to be t is equal to 1 by f. So 1 by 50, it's going to be 0.02. Okay, 0.02 seconds or 20 millisecond. So I will be placing it as 20 milliseconds. So you are able to see a single waveform. Let's increase the timing to 60 milliseconds. So now we are able to visualize, sorry, the frequency here is varied. So frequency, let it be 50 hertz. Okay. 20 milliseconds. So you can
Anna's house nearby Bhamapata.
so you are able to visualize what frequency or what amount of level
Tomorrow morning
your
11 o'clock.
waveforms will be. Okay, here this DC offset, what happens is it adjusts the value of offset value, that is at what particular half you have to cut up your values. Okay, next thing is you can use your power supply SMPS here. So you can simply connect it to your load, and then you can visualize how much amount of voltage and current it is consuming. Furthermore, you have your integrated circuits and all, so you can use these circuits. And next is this holo module circuits. So these module circuits are used for controlling the motors. Okay, L293D, it's a bridge device. So most of your ICs are shift register. All your ICs are available here. With these ICs, you can do your lab experiments. You don't need to go to your lab. You can simply take the power supply here, connect it to a breadboard, and then you can do all your experiments here itself via online. Okay, instead of getting to lab, you can try all the possible combinations which you get in your mind. So while doing in the lab, what happens is without your lab instructor's approval, you cannot switch on your components. Okay, so mostly you cannot redesign your circuits. Okay, so redesigning the circuit, you have to have your instructor right next to you, and then redesign it, and then you have to try it out. So most of the time what happens is while you redesign the circuit, the components get blown off. Okay, so here no problem if it get blown off, just you will be getting a knowledge about it, what has happened. And so you know that it's going to get blown, and now it also gives an instruction why the error has happened. Okay, so you can rectify yourself and you can learn from the stuff. Okay, let's move on to Arduino here. Okay, so before moving into Arduino, so you have a breadboard here. So breadboard, this breadboard, what you can do is it is you are able to visualize it clearly. Okay, so what happens is if I place a pointer there, so it is showing that at the 20th pin terminal. Okay, let me zoom it up. At the 20th pin terminal, F, G, H, I, J, all these terminals are interconnected. For 21, 22, what are all the terminals are interconnected? So usually you will be having a doubt whether this terminal is connected to next which terminal and all. So all your doubts will get clarified here itself while you are placing the components. Okay. Next is your serial and parallel ports. Okay. So you will be having two parallel positive and negative terminal indications. So most of the time they will be using it for positive and negative terminals. So placing a IC here, and then here, okay, positive and negative. So mostly it will be done like this. So here placing the components is very easy. So you don't need to take effort and all. Just drag and drop. Okay, that's all. So it will get connected to the two next terminals, adjacent terminals. So one more advantage is you won't be connecting to the same terminal twice. Okay, loose connection problems can also be solved here. So here loose connection never happens. Okay, so next what we can do is we can place a resistor. Okay, next we will take a power supply. So this terminal is going to be anode. So take the positive terminal from the battery. Sorry. So let us move it over here. So we have connected here. So this is your positive terminal and this is your negative terminal. So from the positive terminal, connect it here, and then again from the negative terminal, connect it to a LED. Okay. So this is how it is going to work. Okay. So connecting via the breadboard, it's an easy job. Okay. So this is the basic instructions with respect to your uh, sorry, what it is, breadboard. So let's move on to the main topic. Okay, the main topic of today is how to use Arduino here and what are the advantages of doing Arduino in this system. Okay, so let me place the Arduino board here. So it's a Uno board. Usually most of them will be developing their knowledge only with respect to Uno boards. Why it is? Because it is bigger in size, it is comfortable to use. So let me tell about the it uses an Atmega microprocessor. So next is you will be having some pins. Okay, let me explain with these pins. So here you will be having your two ground terminals, a 5-volt terminal, 3.3 terminal. So these are the input output reference, input output reset pins. You will be having 6 analog pins, A0 to A5. Okay, these are the analog inputs where you can receive the input. From the input received, so you can make a processed output on the other side. Okay, so here you will be having 14 digital terminals. Okay, so with 0 to 13. So most of the time while using Arduino, it's better to practice not to use this terminal 0 and 1. Okay, why it is? Because it is the transmit and receiving pin. Okay, so to write the program, last class, yesterday's session was with respect to Proteus. Okay, so in Proteus what they would usually do is they would type the code, convert it into Xcode, and after that Xcode you will be putting it in here and burning it. Okay, that the thing you will be doing here. So in real time what you will be doing is you will be connecting a USB cable to this Arduino and then write the program and then burn it. Okay, when your pins 1 and 2 are connected, what happens is it creates interference to write the program in your Arduino board. Okay, so it is better practice not to use 0 and 1 port. So you for regular usage. Okay, usually the 0 and 1 port are used for Bluetooth communication. Okay, for Bluetooth communication, transmit and receiving purposes, most of them will be using this TX and RX 0 and 1 pin to connect to your Bluetooth device. So what we can do is we can use this remaining pins. The one more disadvantages with this microcontrollers is that they produce an output of very low current value. Okay, not so these current values, what we can do is we cannot drive any switch and all. Okay, so with respect to power electronics, so you people are mostly of electrical students. So while doing your projects, what happens is you will be using your switches, okay, MOSFET or IGBT, whichever is your choice of preference. So to drive those switches, what happens is microcontroller outputs are not sufficient to drive those switches. So finally what you have to do is you have to use a driver IR2110 to drive your ICs, okay. So here we won't be using 0 and 1 here. So next thing is, let us start here. So with respect to coding, when you click on code, what happens is uh, most of you would have learned Arduino, or few would have learned Arduino. So if you are good with Arduino, when you know how to code, what you can do is you can, sorry, I will repeat it. You can simply click on blocks and click text, and you can go to the text editor and you can write your code there. Okay, so those who are learning Arduino or don't know anything about it, what they can do is they can use the blocks. These blocks are very much comfortable. Okay, how much comfortable is, let me explain it to you. um, so what you have to do is right click and delete. Let me delete these blocks. Okay, so let us see what are all the available things here. Okay, so for today's class you need to know only a little
Bala, still you are in the meeting room. எனக்கு கட் ஆயிடுச்சு. அதான் அதுக்காக தான் வெரிஃபை பண்ணேன். ரீஜாயின் பண்ணுங்கள். பிகாஸ் எனக்கு நெட் இல்லை. ப்ளீஸ் டேக் அப், அப்படியே கண்டினியூ பண்ணுங்கள். ஓகே. No. Session is 5:30. சொல்லுங்கள் பாலா. சரி. எஸ். Dear participants, there is a technical issue from resource person side. Please bear with us. He will be joining in another 2 minutes. Speaker has joined. Bala, you can share the screen.
1 minute, sir. Connecting.
Yeah.
May I know what time did I left? My sir, my presentation got disconnected.
Yeah,
So that I can continue
exactly
from there.
from this screen. Exactly from this screen.
Okay.
Right now, you are showing one screen, no? So here you got
Okay, sir.
disconnected. Yes.
Okay, sir.
Yeah.
Okay, let us see about the various blocks here. So you will be having your output block, input block, notation block, control, math and variables. What you can do here is just you have to drag and drop the inputs. Okay, so you don't need to type code and all. Okay, just drag and drop. That's all. It is sufficient. So it creates the code automatically for you. Okay, this is one of the major advantage with respect to your Tinkercad. Okay, let's start with the output. So one thing what I have to do is, so the first command is set a built-in LED to high. Okay, so what I'm going to do here is I'm going to either switch on or switch off my LED. So initially what happens is I have set it to low, so it is not going to glow. So my on status is on, so that my Arduino is powered on. So next is stop. So if I give it as high, what happens is my input LED, that is inbuilt LED, starts glowing. So okay, next what we can do is control. So I want to make my LED to blink. Okay, so what I can do is like this wait command in the control system. So I have to, what I want to do is I want to control my LED. Okay, so go to control. So the first command is wait. So drag and drop this wait here. Okay, so what you can do is, so how long it has to wait? It has to wait for 1 second or second. So don't go for milliseconds. So seconds is comfortable. So if you need anything less than a second, what you can do is there you can go for your milliseconds. Okay, milliseconds where it is needed is it's used for controlling your drivers. Okay, with respect to when you are designing an inverter or something, what you need is you need to be working with respect to milliseconds. Okay, let me start the simulation. Okay, after starting it, what happens is my LED glows on for 1 second. So sorry, I made a mistake here. So next what I have to do is I have to switch off. Okay, after switching on the LED, what I have to do is I have to switch off the LED and then start the simulation. So what happens is my LED switches on and switches off at regular interval. Okay, um, control. Okay, okay, now we are able to visualize it. So what happens is my built-in LED is high for 1 second. So this is how your Arduino process. Okay, so it process your commands in a sequential manner. So, okay, first set inbuilt is going to be high, so it is going to be wait for 1 second. For 1 second my LEDs will be switching on, and next what happens is I am giving instruction to turn it off, so it is switched on, so it is going to switch off for 1 second. So let us change it to 2 seconds. Okay, so that my LED is going to be switched off for 2 seconds and then switched on for 1 second. So you can see the time delay in it. Okay, so if you want to make it faster, okay, so where you can, what you can do is you can go with respect to milliseconds. So when you go to milliseconds, mostly I request you to prefer 100. So only then you can visualize it. Okay, uh, so if you are good with the timing, so you can, sorry, here it is going to be 200 seconds. Okay, sorry, 200 milliseconds. So okay, what happens is for every 100 milliseconds it is getting switched on, and for 200 milliseconds it's getting switched off. Okay, so you are able to work with your Arduino at a very higher level. Okay, so next thing is instead of making this particular LED to glow, what you can do is you can so stop the simulation. So next is, this is your Eagle circuit board display. What you can do is you can export it to, you can prepare your own files. Okay, so with that file what you can do is you can do your circuit printing. Okay, uh, let's move out with the code. Okay, one more thing. So this is the code which it was there. Okay, so what happens is, as I said you before, this simulation is capable of converting the set of blocks into codes. Okay, so let's move on and see what is the code it has generated. Okay, so those who know Arduino, this is the basic command which is loaded into most of the Arduino. Okay, so pin mode, so 13 pin, so 13th pin is connected to your LED, this thing. Okay, so here what we can do is, code is already been burned, so let's take a breadboard here. So here you can connect your LED directly, so that is not going to be a problem here. So when you start the simulation, so what happens is your LED burns on, glows same like your thing. Okay, so the only problem here is the output current is maximum of 35 to 40 milliamps. So this amount of milliamps this LED cannot withstand. Okay, this is the information it is giving. Okay, so it is not advisable to connect these types of LEDs here. So it is better to connect via a resistor. So this is the thing which I said you before about the basic electronics. Okay, so this is being helpful for stopping a diode from exploding. Okay, so usually if you place a diode like this, so diodes are of 2 to 3 types usually when you purchase from shops. Okay, these colored diodes, okay, are of they operate at lower current limits. Okay, so it is better to use resistors. So there are some LEDs with plain colors. Okay, simply it will be of white in color. After glowing only we will be able to visualize what color is the LED. Those LEDs are capable of withstanding up to 60 milliamps, so it would not be a problem there. Okay, so let's move on to some Arduino examples. Okay, so what you can do here with it is, instead of placing this LED, I can place a microphone here. So what happens is, it gives just a sound like your ambulance. Okay, you can create ambulance sound by varying the pattern and the time limit. Okay, in the code, let's move on to blocks. So instead of this, what you can do is, you can use another 3 or more set of patterns like this. So what you can do is simply duplicate the block and paste it here. 1 minute. You can simply duplicate the block and paste it here, and then you can visualize. Okay, so start the simulation. So again what happens is, you are able to see the change in the pattern of light. Okay, with this changing in pattern, you can create your own ambulance sound and all, siren sound, or alarm for your college or school, and whatever thing you need, you can create your own alarm with the help of the buzzer. Okay, uh, okay, this is the basic blink. Next thing is, here you will be having analog. So these are all the digital inputs we can give. That is, either it is going to be 0 or 1. Okay, one thing it is going to be 0 or 1, that is high or low. So at high position, what happens is the switch gets on, and at low position, the switch gets off. Okay, next move on with the uh, what we can say it as analog thing. Okay, here you can go with analog. So basically, what you will be doing. Okay. So here what we will be doing here is a count up time. Okay. So count up by so it is simple, just like your for loop. Okay. So for loop, count up by 5 for brightness. Okay, from 0 to 255. Okay, and then wait for 30 milliseconds and then count down. So it is not okay, let me zoom it up. So count up by 5 for brightness from 0 to the set pin 9 to brightness. Okay, so initially this is going to be your simulation. So if I start it up, what happens is the brightness of the LED starts increasing and then it gets reduced. Okay, so how this happened is because of the voltage levels, okay, that we are going to give here. So you can operate them. So for better understanding this, what we can do is we can move to block and text. Okay, so here it is. So to do this type of works, so these things can be done only with respect to your uh, PWM pins. Okay, so here you are able to see a tilt symbol here. Okay, these tilted symbols are your PWM pins. So totally you will be having 6 PWM pins. Those are digital pulse width modulated pins. Okay, so the minimum value is going to be 0 and the maximum value is going to be 255. Okay, so total it's a 8-bit. So 0 to 256, 8 power 8. So this is going to be your brightness. So what happens is this is similar to the for loop which I mentioned it here. So initially they have assigned a variable named brightness. It is equal to 0. And next is ninth pin is going to be my output. Next what I am going to do is count up by 5. Okay, so what it is, here you can see brightness equal to plus 5. Okay, so brightness, it started from 0, it's increasing with respect to 555 up to 255. Okay, so so set pin 9 to brightness. Okay, so what you can do is here you will be giving a analog value that is from 0, 5, 10, 15, 20, 25, 35 up to 255.
Hang ஆயிடுச்சு பாலா.